Stanford University.
All right, so welcome then to lecture number 3 of developing iOS applications. And this is going to be a lecture that is really heavily focused on Objective-C. And you've seen a lot of Objective-C from my last lecture. We did the demo, the walkthrough. If you're doing the homework, you're typing in a lot of Objective-C. But today I'm going to spend some of the time going over what we've already done in a little more formal way so that you understand what the rules are and the syntax. And then introducing some new Objective-C things that we didn't really know when we did that demo. And I'm actually in the middle of this lecture going to go back and redo some of our first assignment based on what I'm going to show you today. And you're not required to go back in your homework and do anything I've done today. And in fact, in general, that's true. The Tuesday lecture never applies to your homework. So anything you hear on a Tuesday lecture, you don't have to rush in. If you've already turned your homework in, that's fine. There's nothing you ever need to do. This happens to be a lecture where, just because of the overlapping of the order in which I'm presenting the information, you might want to go back and do it, but totally up to you, totally optional. You'll be doing plenty of what I'm talking about today in your next homework, so there's really no reason to go back and do it unless you just want to for fun. So these are some of the Objective-C things I'm going to be talking about today. It's not everything in Objective-C, but it's all I can fit into one day, basically. If we do, by some miracle, have a little time left at the end of the day, I'll start going into some of the foundation framework. So some of the objects like NSString and some new objects like NSArray that you haven't seen before. Try and give you a little bit of overview of what those classes are, how they work, because they're really fundamental to writing anything serious. Okay, so we really need to know that. But it might be that that all gets pushed until Thursday. We'll have to see how it goes today. So Objective-C. I'm going to start in Objective-C by talking about method syntax. You've already sent some messages. You've already defined some messages in the walkthrough. But I just want to make it clear about what the syntax actually is specifically. The first thing is that little dash at the beginning, and we had a question about that last time even. The dash there either is a dash or a plus. Those are the only two things that first character of a method declaration can be. A dash means it's an instance method, and a plus means it's a class method. And I'm going to talk in detail what the difference between those two are. So that's what that first character is. Next, you have the return type of the method. All right, we've seen void as a return type. That means it doesn't return anything. That's different from not putting anything here. Okay, if you put nothing in, no parentheses here at all, then that means you're returning an ID, which you'll recall means an object that could be any kind of object, non-statically typed. You're not telling the compiler anything about it. You're just saying it returns some kind of object, pointer to an object. This particular example returns a pointer to an object as well, but we statically typed it to be NSArray so that the compiler knows that we're returning an array. So when it sees someone call this, it can kind of check to see if maybe you send array messages to that thing you get back. But we'll talk a little bit about static typing later today as well. Okay, so that's return. And the return type obviously can be int or double, any C primitive type. It can even be a C struct, okay, which is not uncommon in iOS development to be passing C structs around as well. So this is the name of this method. This is a two-part name, okay, because this method takes 2 arguments. So the first part of the name is ships at point colon. The full name of the method is ships at point with damage, or ships at point colon with damage colon, depending on your preference. And so that's the first part, and this is the second part of the name. So it is kind of goofy to look at this. You know, you've probably never seen a language like this where the name of the method is split up. Okay, it's parceled out amongst all the arguments. Kind of strange. I guarantee you'll get used to it really quickly, and you're going to find, I think, that you really like it. Okay, I really think it's great. I think it makes the code read really smoothly. So, but it is definitely unusual. This is the type of the first argument. Okay, this one happens to be a C struct. CG point is a point on the screen, a graphical point. You'll be seeing a lot of this later in this class. If this is missing, that also means that this argument is an ID. So anytime a type is missing in the method declaration, it means the argument is of type ID. In other words, pointer to object of unknown class. This is the second argument. This one's a bool, just for variety. Here's the name of the first argument. In the declaration, it doesn't really matter what this is, but it can't be blank. It has to be at least one character. Normal C rules apply as to what variable names can be. Can't start with, percent and things like that. But mostly this matters in the implementation, because when you have the implementation of this method, this is the name of the argument that you're going to use in your implementation. It's going to look like a local variable. This is all just like any other language, nothing particular exciting there. And then that's the second argument damaged. Okay, so that's it for method syntax. Now, sometimes methods have really long names with lots of arguments, and each argument is really long. For example, here's one: split view controller will hide view controller with bar button item for pop over controller. Okay, now that's really long. If we had that all in one line, we'd be scrolling our Xcode sideways, for 5 times the width of our screen. So what we do is we split it into separate lines and line up the colons. Okay, and then you can see why that would make it a lot clearer to see what this method is. And we do that both in the declaration, which is what this is, and also when we're calling it. We would open square bracket, receiver, then we'd say split view controller, colon, give our argument, go to the next line, line up the colon, give the next one. Okay? So line up the colons. This is a delegate method for split view, and you're going to see that there's a lot of long method names, especially delegates. IB action is a special little thing. It's just typedef or # defined to be void, so it doesn't return anything. And it's an indicator to Interface Builder, as we talked about last time, that this is something Interface Builder should pay attention to. I did want to use this opportunity to show you a couple of things here. One is that the argument to an action does not have to be statically typed. We had the first one, digit pressed UI button star, but we could have just said digit pressed ID. Okay, sender, ID meaning pointer to any object. Now, what's the difference there? Well, Interface Builder, in the second case with just ID, it'll let you wire that up to anything that can send a target action. A slider could send this, a switch, etc. Whereas when you put UI button star, Interface Builder will only let you drag it from a button. So I recommend strongly statically typing it, unless, in fact, your digit pressed is able to receive a message from different kinds of objects and do the right thing. However, if it's doing that because it's ignoring the argument of the sender, then you can use this bottom form of target action, which has no arguments. Okay? Perfectly valid kind of IB action, no arguments. Notice I put a third one in there, which is colon sender. That's just to emphasize again that if you put no type for an argument, it means ID. So the second and third lines at the bottom there are the same, just absolutely identical. Okay? But I recommend the parentheses ID because it makes it clear to the person who's calling it and to anyone looking at your code that that's what you intend. You didn't just forget to put the type in there. Okay? So instance methods. Remember I said there's 2 kinds of methods. There's instance methods and class methods. Instance methods are the ones that start with a dash. Like our target action thing is an instance method. This is quite a tongue twister. Say instance method 5 times fast. It's quite difficult. These are the normal methods that you're used to in other object-oriented programming languages. You send a message to an object, it invokes an instance method on the object. It's called an instance method because you have to send it to an instance. All right? And since you are sending it to an instance, meaning, and hopefully you all know what that means, an instance of an object means an actual instantiation, and something where you've allocated the memory for an object and it exists now. You can access the instance variables inside your implementation of an instance method as if they were locals, just like in any other object-oriented programming language. You don't have to say, self, dereference self or anything. Just if you say an instance variable's name inside the implementation of a method, it just means use that instance variable. Compiler knows what you want. And of course, you can send messages to self and super inside of instance messages. And what that means is send this to this same instance, okay, and call this method on this same instance. The only difference between self and super is that super means send it to this instance, but start using my superclass's implementation. In other words, use inheritance. Okay, object-oriented programming. Nothing particularly exciting here. So that's the declaration and implementation of it. How about the syntax for calling it? Again, you've seen it. Here's one with 3 actually different arguments: ship, drop, bomb, at, from. And so this might be some spaceship game. It's calling drop bomb at from with these 3 arguments, and the return value is some Boolean, maybe whether the ship was destroyed, I guess, something like that. So you're familiar with this. Again, if this was really long, we might line up those colons. Some people like to line up the colons for multiple arguments all the time, just to make it clear this is, here's the 3 arguments. Totally, that's your preference, up to you. Xcode, I believe, will help you with that. If you go before that at and you just hit return, it'll line the colons up for you. Okay? All right, class methods. Now, sometimes people get confused about class methods or think that it's really hard to understand just because a lot of languages don't really have this mechanism. But some languages do. It's not that unusual. And it's really quite simple. Okay? You can think of class methods as just a group of global functions that are collected for this class. Okay? There's really nothing special about the implementations of them. They're really no different than if you just declared a C function. Okay? But it happens to be a method, which is nice because it looks nice. And you get inheritance. Okay? So that's the only difference. Now, we'll talk in a second here about the syntax for sending a message, a class method. But the implementation of it, we're going to talk about the implementation of it first. The reason you would use a class method, there's 3 main reasons. You can use it for whatever reason you want if you want a global function. But there's 3 main ones. First one there I have listed is allocation of memory for the object. This is the most common cause of calling a class method is you need to allocate memory for it. And so this method alloc, which you've already seen, the calculator brain, we alloced it. That alloc is just a method in this object that says allocate enough memory to hold this object, all its instance variables. So that's what alloc means. You send that to the class. Another reason to have a class method is you want some global object. Okay? Something an object that's going to be shared throughout your whole program. So you don't want to create a new one every time someone wants to use it. You want to have a shared one. So I've used the example here in a spaceship game of the mothership. There's only one mothership. You might be allocating a lot of little ships, but everybody wants to share this one mothership. So you might have a class method called on ship called mothership, and it'll give you that one instance. It gives everyone the same instance who calls it. And then lastly, you might have utility functions. Like here's a little function that you could send a ship, and it tells you how many turrets are on a ship of a certain size. Now you're not sending this to a certain ship. You're just saying if I had a ship that was of a certain size, which I've had be an int, probably a little simplification, but a ship of a certain size, how many turrets would it have? So you don't have to actually create the ship to find out how many turrets it's going to have. You can actually ask the class for information. So this is the reasons we use class methods. One thing to be careful to understand, in a class method you cannot access the instance variables. Okay, because you don't send it to an instance, right? So the instance variables, don't access them in the class methods, ever. All right, it makes no sense to do that. Okay? You can still send messages to self and super, but it just means other class methods. So if I say inside of a class method, a square bracket self, call a method, that other method better be another class method, because I can't send an instance method to self because I'm not an instance, okay? Same thing with super. I can call class methods in my super class by doing super, but it's no instances here. So here's some example calling syntax, the other side. So the first line you probably recognize from our demo last week, calculator brain star brain equals square bracket, calculator brain alloc. That's a class method call. Okay, I'm sending the method alloc to the class calculator brain, and so now you're seeing the syntax for how you call the class method, which is you just put the name of the class and then you call the method. Okay, whereas in instance, the receiver at the beginning of the square bracket is some variable or something that contains a pointer to an instance. Here you put the actual name of the class, like calculator brain. This is one of the reasons we have all our classes start with a capital letter, so that it's very obvious you're sending a class method here. That calculator brain isn't some variable that points to an instance of something. It's clearly a class name. And then I'm sending init to the result of that. Init is not a class method, okay, because alloc returns an instance, okay, memory space allocated for an instance, and then I'm sending init to that instance to initialize it. Okay, we're going to talk a lot more on Thursday about allocating and initializing objects. So for today, you're just going to have to kind of suspend your disbelief on how you allocate and initialize objects and who manages the memory for them. We're going to talk all about that on Thursday. That's a very important topic, but we're not going to be able to cover it today. So the rest of these are just examples of what I was showing above, like the mothership. You'd have a ship star, the mothership. That's a pointer, an instance pointer. Equals ship, again I'm saying the name of the class, mothership. It's going to return that instance. It's going to be the same instance it's returning to other people calling mothership. It's not going to create a new mothership every time someone calls it. The next line, though, is creating a new ship every time, and that's something I made up called ship with turret count of 5. Okay, you pass 5, it creates you a ship, a new one, with 5 turrets and gives it back to you. So that's different than mothership. It's not a shared one. And then the last one, that's just showing an example of using like a utility function. Okay, I'm just getting the turret count on a medium-sized ship there. All right, so everyone got that? Class methods? Question?
Got a question on the ID. Can you say plus ship, mothership, and would that also work?
Yeah, so up there, the question is when it says on the slide plus parentheses ID mothership, could I have said plus parentheses ship star mothership? Absolutely, I could have. And probably that would be better. Okay, I only put ID just to kind of have some variety here. But yeah, if it always returns a ship star, like a ship or some subclass thereof, it should return ship star. So that's a good question. All right, so that's it for methods. Now we're going to talk about instance variables. Okay, one of the things that people always want to understand about instance variable is their scope. Who can see these instance variables? All right, so by default, instance variables, if you don't say otherwise, they're protected. Okay, just like other languages, protected means the class can use them in its implementation, and also subclasses can as well. Okay, so if I write a subclass, I can just reference those instance variables in my instance methods, just as if they were instance variables in my class. But you can also mark instance variables private or public, and that's exactly what you would think. Private means only my class, not my subclasses, can see it, and public means anybody can set this instance variable. Okay, so here's what the syntax looks like. I'm not really going to look at this, talk this in detail because of what I'm going to say on the next slide, but if you want to go back and look at the slides, it just talks about how you do this. It's pretty obvious. You put the keyword there, and then every instance variable after the keyword will have that particular scope until you put a different keyword or until it ends. So that's that. But the reason I'm not going to spend much time on this is because my next slide is going to say, forget everything on that previous slide. Okay? And that's because in Objective-C, really, we want to mark all of our instance variables private, perhaps protected, but likely private. And we want to use this new mechanism, which I'm going to talk about today at length, called properties. Okay? And properties allow us to use a new notation in Objective-C that you haven't seen before, called dot notation, to access the instance variables in a safe, secure, subclassable way. Unlike making them public or even protected, where someone might be setting that instance variable right out from underneath you in a subclass, or setting it some way that you want to hear about, or that you don't like, or is out of bounds. Okay? So we don't want to have our instance variables just being set directly. So we're going to use properties and dot notation. So what is this? The bottom line of properties, or the basic idea, is you're going to use methods to get and set your instance variables. Okay? And you're going to use these methods not only for other people, including your subclasses perhaps, to set and get these things, but also just random other people who you want to make some instance variable basically public, but you want to control access to it. So you're going to use set and get methods. Now, the key to making this work is actually the naming convention. This is what the naming convention looks like. The getter is going to take no arguments, and it's just going to be the name of the property. So in this case, I have a property here, which is I. I happen to have an instance variable, private, that has the same name. And so I have a method I. So that's it for the getter. The setter has a very important restriction on its naming. It has to start with S-E-T, lowercase, and then a capital letter. Okay? Always has to be that way. So if I had S-E-T-E-Y-E, all lowercase, that would not be a setter for this property. Okay? It has to have that capitalization. That is one of the reasons we have a convention in Objective-C that we always have our instance variables start with a lowercase letter, like I does right there. That way the set I kind of stands out a little bit. The setters are clear because it got this capital letter after the set. All right, so that's just, again, naming convention. But the set I is, you have to do that if you want this dot notation thing to work. We're going to talk about that. So how does the dot notation work? Well, if you have these two methods, I and set I, now somebody else can basically use this notation right here, where they say some object dot I equals some value, and that calls that setter, set I, with the argument. I don't know if you can even, maybe that's too dark, but so that's the dot notation to set. And then the next line down is the getter. Int I value equals some object dot I. And that calls the getter. Does that make sense? I'll do that. I don't know if that helps or makes it worse. But so by using this dot, there should be a dot in the first one there too. The dot I notation to either set something equal to it or to get the value of it, you are essentially calling those two methods, I and set I. Everyone understand that? That's the fundamental part of properties. Now, there's much more to it than that. One thing to note is the capitalization. I already talked about that. So we don't usually, though, do what you see up here where we have I and set I. Okay, even though we can do that, and it does work. Okay, you can use the dot notation if you do that. Usually what we use is this new keyword called @property. Okay, and this is what @property looks like. So here I say @property int I, and that basically declares those two methods for me. So I can take them out of my header file, the I and set I. Okay, so those go away. So this is what my API ends up looking like. @property int I, that means there's an I and a set I. Now everyone can use dot notation to set the I or to get my I, and it's always going through those two methods. So I have control of it. And subclassers can override those methods if they want to find out when I is being set, or they want to find out when someone's asking for I. All right? Or if they want to control how I is set. Maybe I can only be a positive number. We'll see an example of that in a minute. Okay? They can override that and control that. So you can also throw in the keyword read-only. So @property read-only int I. That'll make it so that it doesn't create the setter. Okay, so that's a read-only property. You can only get it. That's very common, right? You have an instance variable. You want people to be able to read it, but you don't want them mucking with it. You just want them to be able to see what it is. There's no way to have a set-only property, basically. There's no way to say @property write-only. It's read-only or read-write. Okay? Now, this @property thing, though, this is where you get to a little bit advanced usage, but it's important to note, it doesn't have to match the name of your instance variable. So for example, look, I've got an instance variable here, p underbar I, maybe that's private underbar I, maybe I put p underbar under my private instance variables, and yet my property is still called int I. Okay? Now, that turns out to be okay. In fact, you don't even need to have an instance variable. You can just do @property int I. So it's not really linked to the instance variable in terms of its declaration. But what's important, no matter how you do it, you have to implement what you say you're doing in your header file. Okay? So hopefully this will make it clear what I'm saying in the last two slides. So let's consider the normal case. I've got private int I. I've got the property int I. In my implementation file, I have to implement I and set I. And I'm just making it so that it returns my instance variable and it sets my instance variable. Right? Super simple. This is the simple case. But what if my instance variable was p underbar I? Well, then I just would have to change my implementation so that it returns p underbar I, and when the set happens, it sets p underbar I. Okay? So see how that works? So it's all about the implementation as to how it matches up with your instance variables. And then what if I had no instance variables? Here I've got I've made it read-only. And see, I just implement -int I, which is the getter. And that's all I'm required to implement because it's read-only. And I just return some calculated value for I. And I'm not returning an instance variable. I'm just calculating it from some other data or something. All perfectly allowed, perfectly reasonable. Okay? But the point is, I've made a public declaration of this @property that people can use this dot notation to get and set the values. And I just have to make sure my implementation matches. Now, I'm going to make life even easier on you by providing another keyword which will implement those two methods, the setter and getter, for you in your implementation file, as long as you're doing it in a straightforward way. So once again, here's the normal case. My instance variable, I'm just returning it and setting it. In this normal case, I can put @synthesize I instead of my implementation, and it will interpret that to mean you want a setter and a getter that sets and gets the instance variable with the same name as the property, right? The straightforward case. Now, what if my instance variable was the p underbar I? Well, I can do that too. I can say @synthesize I equals p underbar I. Okay? And then it'll automatically know to do the set and get on that other instance variable. Now, what if I have no instance variable? Then I can't use synthesize. Okay? If I have no instance variable, like the case where I'm returning this read-only I have to implement that myself. There's no way synthesize can synthesize any code for you. All right? Yeah?
Where are you establishing what type of variable I is?
You mean what its type is? Like the question is, where are we establishing the C type or the type of I? And the answer is in the instance variable. That's where I'm doing the int I storage. And in the property, you can see it's @print property int I. So both places I have to say what type of object it is. All right, so that's synthesize. Very, very valuable. If you use synthesize, you can still implement the setter or the getter, or both. Okay? Your implementation will trump synthesize. Now you might say, well, why would I use synthesize and implement? Well, the answer is you want to use synthesize to synthesize both the setter and the getter, and then you're going to change the getter, or you're going to change the setter. So here's an example where I am using synthesize so that I have the getter and the setter, but then I'm providing my own implementation for the setter to make sure that I is never set to be a negative number, right? I just have put a little if in there. If and int is greater than 0, then I set I. But if it's 0 or negative, it just does nothing, right? So if I say something dot I equals -3, that does nothing. If I say something dot I equals 4, it'll set I to 4. Okay, so it's perfectly fine to use synthesize and then implement one or the other. You can even implement both. Then your synthesize is just wasted code because it's not going to be ignored. It's quite common and probably recommended to use dot notation with self inside the implementation of your methods. Okay? So even when you're accessing your own instance variables, sometimes it makes sense to use self dot the property name. So for example, in an implementation, I could say int x equals I. That would set a local variable to my instance variable I. That would work fine. But I could also say int x equals self dot I, which does not do the same thing because int x equals self dot I calls my getter. Okay, so if my getter does something in there, in addition to returning the value, that's going to happen. But it's generally a good idea to do that, but you can also get into very big trouble doing that. For example, when you're in the code of your setters and getters, you want to be careful about saying self. Okay, look at this code right here. Here's my setter, set I to an int, and I say self.I equals an int. Okay, what's the problem with this? Infinite loop. Because that line self.I equals an int is going to call my setter, and I'm in my setter. So it's going to keep going around and around and around, constantly calling my setter, infinite loop forever. Okay, so be a little careful in your setters and getters when you use self dot whatever. If you have a method where you're calling self.I, 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 25 times in your method, generally good form sometimes. If you're sure that self.I is not going to be changing out from under you, maybe create a local variable at the beginning. Int local I equals self.I, and then refer to local I everywhere the 20 times, so that you're not constantly calling that getter over and over. However, don't worry too much about that getter being a lot of overhead. Oh, I'm calling a method every time. The amount of overhead inside of your methods compared to the overhead to draw on the screen is just infinitesimal. Okay, so unless you're doing some kind of 3D graphics thing, it's very computational intensive in a tight loop. I wouldn't worry about the overhead of calling a getter compared to I'm going to tell the screen to update bits, okay, which is constantly happening in an iPhone or an iOS app, right? You're constantly updating the screen. Very heavy operation compared to going in a loop and setting self.I a few times. All right. Here's the setter. Here's an example of the setter one you can look at your leisure, where the setter can also easily loop. or the getter, whichever one that was. All right, so why do we do this property thing? Okay, so why do we implement all this dot notation, syntax, and @sign property, @sign synthesize? Well, the main reason is safety and subclassability of your instance variables. Okay, safety in that you know when someone's setting an instance variable, you can bounds check it, you can know when it happens. Same thing getting. You can make sure you never return a bad value. It's, you can find out when someone asks for it. You might want to go do something that's, time intensive at that point, fork off a thread, I don't know what, but you can find out what's going on with your instance variables. But they chose the syntax very specifically to match what the syntax is for C structs. Okay, and I'm going to show a quick demo of this, or a quick example of this. I don't want to spend too much time on this, but here I have a C struct called point. It has an X and a Y in it. It just represents a point, let's say. And then I have an object called bomb, which has a property, which is a point, perfectly legal, called position. Maybe it has some instance variables in there. I don't know. But it has that public property. And then I'm going to have the class I'm going to implement here called ship. It has 3 instance variables there, width, height, and center. Notice how I put float on the same line, width and height. That's perfectly allowed, by the way, in Objective-C. So I've got 3 instance variables, and then I've got 3 properties that match up to them. And then I've got this method gets hit by bomb, which is a method that takes a bomb and it returns whether this ship gets hit by that bomb. So we're going to implement ship right here. Okay. So yeah, so it returns whether it's ship. Okay, so here's our implementation of it. Notice the first line in my implementation, I synthesize my 3 properties. Okay? Synthesize width, height, and center. So now those properties are synthesized. Now, the gets hit by bomb, so it's very simple implementation. I'm just going to go left edge, right edge, top edge, bottom edge. I took out some of the code there, and then I'm just going to see if the bomb is inside my edges. So super simple implementation. That's not the key. I want you to look at this notation, though, this self.center.x notation. All right? So here we're accessing our own instance variable called center by calling self.center through a dot notation, our property. And then I'm using dot notation to access the C struct that comes back to get its x. Everyone understand what's going on there? So you can see in one little term, I've mixed both dot notation for getting my own self.center with the dot notation to getting that x out of that C struct, the point struct over there that had an x and a y. All right? Now, down here, so here's a couple more examples of it. Here is a couple more, or another example of where I'm using dot notation to reference an object property. This time, it's another object, the bomb. Okay, I got the bomb. It has a public property called position, which is a point, and I'm accessing that. And then here I'm doing the same thing, accessing the C structure using dot notation. So you can see how this implementation of this method has a lot of method calls in it, actually, but they're all hidden. They all are these setters and getters of the dot notation. Okay? And it also looks very similar. C structs and objects look similar when you're accessing their data. Instance variables in the object case, the members of a C struct. Now, why have they done this? The reason for this is that C structs are a lot like objects that don't have any methods on them. Okay? And there's a lot of C structs that are passed around in iOS. As you can imagine, points and rectangles, sizes, things like that, that don't really need methods. There's a few C functions to manipulate them. They don't really need to have the overhead of being objects, but they act a lot like objects. Right? They carry data around, and you're passing points as arguments all the time. So you want the code to kind of look similar when you're doing a similar thing, which is accessing the data of something. Okay? That make sense? All right, private properties. Do all @sign properties have to be public and in your header file? No, they do not. Okay, there's a special magic that you can do. Okay, you're just going to have to remember this magic to put an @sign interface at the top of your .m file, which is private interface. And you can put properties in here. You can also put methods in here, and then implement them in your @sign implementation. And here's the special magic. It's the parentheses there. You say @sign interface, my object, parentheses, open parentheses, close parentheses. Okay? Everything you put in that interface is kind of added to your interface. You can put methods in there. You can put properties in there. You cannot put more instance variables in there. Okay? All your instance variables have to go in your header file. Okay? That's a restriction. basically on strict C is that it needs to know the size of that instance variable structure when it's allocating the object. So you cannot put more instance variables, but you can put properties. So for example, here I have added this property my eyes only, which is a double, and then I synthesized it, just like I synthesized I. And presumably my eyes only is an instance variable, a private instance variable declared back in my header file. Okay? And I can call this property using self.myeyesonly. That's actually the only way I can call it, because no one else can call it. It's private. Everyone okay with that? There's more to think about with properties. I can't tell you everything about them because when a property is an object, there's memory allocation to think about. Okay? Right? If I have a property and I get an object from somebody using a property dot notation, who owns that object? Who has to free it? Things like that. We're going to talk about all that on Thursday, so hand wave today. So demo. Okay, so I'm going to just quickly go here back to our walkthrough code. So this is exact walkthrough. Probably this Xcode hasn't even been closed since last time we did this. And I'm going to change the code that we did last time to use dots instead. Okay, just so you get a feel for what this all looks like. I'm going to start with the calculator brain. We actually have something that will work with dot notation already. It's this guy right here, set operand. Okay, we don't have a getter for this, but we have a set, right? A set operand. So we could actually use dot notation right now to set operand. So let's go to our view controller to where we do that, which is right here. See, there's self brain, set operand to this double value. I'm going to comment this out so you can see it while side by side. How would this look? Self brain dot operand equals display text double value. Okay? So this guy might look funky because we got square brackets self brain, which returns our brain object, and then we're dot notating it, but that's perfectly valid. I told you this nesting of message sends that return objects, perfectly valid, is valid here too. So that's the way we use dot notation already. We haven't done any @sign properties or anything. And in fact, we could go back to our calculator brain. We could make this @sign private, and it would all work perfectly fine. So if I make this @sign private, sorry, it's kind of an odd typing angle. And so here I can build and run this. And this will all run fine. You know, 2 divided by 3 equals. Okay, so that's all working great. But this is really not in the spirit of properties to just have this set operand and all that. Really what I want to do here is say @sign property double operand. Okay, so I don't even need this. And similarly, over in my implementation of calculator brain, I don't need to have this. I'm just going to use synthesize. So I'm going to get rid of this and say @sign synthesize. Ugh, this keyboard. Synthesize operand. Okay, so now I've got the setter and the getter for operand, and synthesize is automatically going to use the instance variable with the same name, which I have right here. So now this is good, so I can run. Still will work. 5 times 9 equals. Okay, still working. But that's not the only place we can use dot notation in this application. In fact, there's a lot of places we can use dot notation. For example, all the places where we get the text out of the UI label, or set the text in the UI label, or even where we get the title label off of the UI button, those are all properties of those objects, right? The text that's in the UI label, that's a property of it, an @sign property. Same thing, the title label is a read-only property of the button. You can't set the title UI label that the button's using to draw itself, but you can get it. Okay, so what would this line of code, for example, look like? So let's get rid of that. This would be NSString digit equals sender.titleLabel.text. So you can see it kind of cleans up the code and makes it a little more readable and nice in that way. And of course, we can keep, you know, nesting still works. We can send a dot notation thing to something we just got back from the dot notation. Similar here. There's a lot going on here we can fix. So this could be display. Whoops. Display dot text equals display dot text string by appending string digit. Okay? So see, I'm here using the setter and the getter for display text right here. So display has a method called setText and has another method called text. It probably synthesizes them, or at the very least, it defines them as an @sign property in its API. Same thing down here. Look at this line of code. I'll do it after to be consistent. This line of code just becomes display.text equals digit. Okay. So that's kind of nice code. What about down here? This is kind of messy right here. This self-brain. Brain is just an instance variable of our class, right? Our brain that we're using. So we should be able to use a property to get that. It'd be a read-only one because we don't allow anyone to set our brain. We create it. It's also kind of private. I don't think we want other people calling things on our brain in our controller. So let's create a private one for that. So I'm going to go up to the top here, @sign interface, calculator view controller, the magic parentheses, @sign property, read only. It's a calculator, brain star, brain, end. Okay, now I could synthesize that by saying @sign synthesize, but I actually don't want to because I do something more than synthesize would do, which is I lazily create my brain if it doesn't exist. So I'm just going to leave this method exactly as it is. I'm not going to change it at all. But I can change the calling code to say self.brain.operand. Use dot notation. Make sense? This right here can be display.text double value. Right? We also, just to show you how that operand, when I added the @sign property for the operand on our brain, it also made the getter. Let's use that getter. I'm going to take away this result. Here, let's copy and paste. I'm going to take away using the result of perform operation, which conveniently return the value of our operand. And I'm going to go here and say brain, self.brain.operand. Now, notice here, I definitely want to say self.brain.operand. If I just say brain.operand, it's not going to work because brains might not get lazily instantiated. It might work here because I might call self-brain before this, but this is a case where you've got to be careful to make sure you're calling self.brain and not just regular brain. Okay? This here also could be self.brain, and this could be display.text equals. Okay? Oops. D. There we go. So you get a feel for all these dot notations, how you do it? Make sense? And so let's run this. It should all run. 2 + 3 equals. Okay, still working. All right? So that's dot notation. You want to use dot notation. Okay, dot notation, yes, it's optional. We obviously could do this whole program without dot notation, but it makes code more readable, and it gives kind of an indication to your reader of your code. This is an instance variable, or not really an instance variable, but a property of my object that you're setting and getting when you use dot notation. When you do square brackets to set it, yeah, that's legal, but it kind of makes the reader think, I'm calling some method. What does this method do? Is it a shoot method? I'm shooting? No. So when you call with the dot notation, it says I'm setting and getting information. Maybe in a structured way, but I'm setting and getting. Okay? So that's properties. Very important thing. That's why we spend so much time on it, to make sure you understand it. Starting with your next homework, you want to use properties whenever it's appropriate. In other words, whenever you're setting or getting data out of an object, you want to use dot notation and properties. Okay? That's going to be on your evaluation thing section, is uses properties when appropriate. And don't use properties when it's not appropriate. For example, some people want to use a property anytime they have a method with no arguments, like spaceship shoot. Sure, you could make @sign property read only spaceship shoot, but that's not really, it doesn't return anything. It's really, you'd be torturing properties into something they're not. Okay? Shoot is an action. You want to use square brackets. Ship, shoot. Okay? All right. Shifting gears now. Talk about dynamic binding. This is the big difference between Objective-C and probably most of the other programming languages that your object-oriented programming languages you're used to is dynamic binding. You've already seen the two ways that you can declare a pointer to an object. In other words, a storage location that points to an object. One is like NSString star, which is statically typed, we call that, static typing. Not static binding, static typing. And then ID, which just means pointer to some object. We don't really know what type it might be. By the way, you never use ID star. Okay? ID star would mean a pointer to an object. Like if you were creating a C array of them, maybe, but you're never going to do that in this class, that's for sure. We have array objects for that. And if you do ID star, you're probably just forgetting that ID already kind of includes the star, right? It's already the pointer. Okay, so ID star, don't use it. The key to dynamic binding is that the decision about what code is going to be executed, literally what function underlying is going to be executed on the processor, is made entirely at runtime. Okay? Always entirely at runtime. Whether you say NSString star or ID, doesn't matter. It's always going to make that decision at runtime. And in fact, the NSString star is really only an aid to the compiler to help you find bugs in your program. It is really nothing to do with the dispatching of which messages are sent and things like that. Okay? So that's an important thing to understand. NSString star, ID, exactly the same at runtime. In compile time, the compiler can look at that NSString star and divine that, oh, you think this is an NSString star. I better check to make sure you're sending messages that are string messages. But that's just the compiler helping you. Okay? That is not anything about the code that's generated. The code generated would be exactly the same. Okay? Obviously, if neither the class of the receiving object when you send a message nor any of its superclasses implements that method, your program will crash. It will raise an exception. And if that exception is not caught, which it isn't by default, your program will crash. Okay? So you got to be careful, and that's why we use static typing as much as possible so that the compiler can help us as much as possible to not have this situation where our program is crashing. Okay? Now, it is legal, and actually sometimes even good code, to cast an object pointer to be statically typed. So someone gives you an ID, or maybe even a already statically typed thing in your program, and you cast it using casting notation, just like in C, parentheses, the type in the middle in front of the variable. You force it to be a certain type. Okay? So for example, here I have ID obj, which I created somehow, who knows how. Maybe someone gave it to me, or I allocated it and initted it somehow. And then I'm saying NSString star s, which is a statically typed pointer to a string, equals that object, but I'm casting it to an NSString star. Okay? So if on the next line I send a string message to s, the compiler's not going to complain, because s is an NSString star. And the compiler's also not going to complain with this line of code, this casting. It assumes when you're casting that you know what you're doing. So you better know what you're doing when you're casting, okay? Otherwise, you can get yourself into situations where you're going to crash at runtime because the compiler can't figure out, the compiler thinks that obj is a string because you casted it to that. And so it only checks to make sure that s is getting sent string messages. But if, obj is actually an array, then, the next line of code that accesses s is going to crash. So casting does nothing, again, in terms of what happens at runtime. It's purely a thing for you and the compiler to talk to each other about what's going on. Okay? Now, why might this be good code? Because there's a way in Objective-C to find out, to ask objects what class they are. Ask them whether they respond to a method. Okay? And your first homework, or your second homework rather, this week, is going to require that you do that. Not because it's not common that you're going to want to do it, but because I want you to understand about the dynamic binding and about how to ask an object what class it is. Okay? I want you to understand that it's not, even if you're statically typing, it's not binding those message sends at compile time. It's doing it at runtime. So that's why this assignment is going to ask you to do that. So let's talk about object typing. I'm going to give you some examples here. So I've got a class here, vehicle, and a subclass of it called ship. It only has one method called shoot. Okay, so this ship is going around shooting at things. Here I'm allocating the ship, and then I'm sending it the message shoot. Okay, now compiler is all good with this so far. No problem, right? Because ship alloc returns a ship star, and then init returns either a ship star or an ID. We'll talk about that later. And it assigns it to a variable ship star. That's fine. And then shoot, that's fine because it knows that s is a type ship star and shoot is implemented by ship. Now it's sending move to that ship star. Okay? Compiler also has no problem with that because it inherits move from vehicle, you see? Vehicle implements move. So the compiler knows about inheritance, and so it's like, cool, no problem. This is all normal object-oriented stuff, as you would expect. Now I'm assigning a new variable vehicle, star v. So this is a statically typed pointer to an object of class vehicle. And I'm assigning s to that. And the compiler's not going to warn me here, because a ship is a vehicle. So it's perfectly fine for me to set a vehicle variable to be a ship. Again, normal object-oriented stuff here as well. Okay? But then, if I say v shoot, the compiler's going to get upset with me. Because vehicle, look at the class vehicle, it does not implement shoot. And even though v contains a pointer to a ship, we only know that because we know we made that assignment, the compiler doesn't keep track of that. Okay? It can't really. There's no way for it to kind of watch that as things are passed around. So it's going to look at this line of code and say, whoa, you know, vehicle does not implement shoot is what it's going to complain. Okay? Everyone understand why that is? Next, I'm going to have an object. Again, I don't know what class it is, just some random object. And I'm going to send it shoot. Now, this surprises people. The compiler is not going to warn me here. Okay? Why not? You could say, how does it know that obj responds to shoot? And the answer is, it doesn't. But it knows that there's a method shoot out there somewhere, and that obj might respond to shoot, so it's not going to warn you. Okay? There is a level of compiler warnings where it will give you kind of low-level warnings where it will say, this object might not respond to shoot. Okay? And I'm not sure whether that's on by default. We might talk at a Friday section, or I might send some email about how to turn that on, because that's valuable. But sometimes you don't want that. You actually know what you're talking about. But the bottom line here is the compiler doesn't know what to do here, because it doesn't know the class of obj. Okay? So that's why we don't want to send messages to IDs directly. We want to statically type them first if we can. So here's another one. So now I'm sending obj to this method, some method name that no object anywhere responds to. Well, the compiler's definitely going to warn about that. If it's never heard of that method, it knows for a fact obj can't be responding to it, so it's going to warn you about that. In fact, that'll probably be a build error, I think, actually. It might be just a warning. So now I'm going to create a little string here, an string star hello, and I'm initializing it with @hello. You know that we can do that. If I send hello shoot, obviously the compiler is going to warn me about that. It knows that shoot is a ship method. It's not a string method, so it's going to warn me. That's good. Here I'm casting hello into a new variable called hello ship. Okay, so I'm creating a new pointer, hello ship, which is a ship star, and I'm casting hello to be it. No warning here because we're casting. And now I'm sending shoot, and the compiler's like, okay, we're good now. Of course, this is a guaranteed crash at runtime, right? Because when you send shoot to a string at runtime, it's going to crash. But the compiler's not having any problems with it. Here's another thing, too. If I just send a message to hello, but I put a little cast ID in front of it, in line, that'll also keep the compiler off my back. It'll also crash at runtime as well. Okay? But you can cast on the fly, too. All right? Does that make sense? I just wanted to go over this casting thing. Yeah, question?
Where you say equals star v equals s.
Yeah.
After that, could you say like s equals, or like star s equals v, like copy it back?
Yeah, can you say, so the question is it legal to say ship star s equals v, equals a vehicle? And the answer is no, okay? Because a vehicle is not a ship. A ship is a vehicle, but a vehicle is not a ship. Everyone understand that? It's kind of an object-oriented is-a thing. It's got to point in the right direction. Inheritance got to go the right way. So no, the compiler would warn you if you said ship star s equals v after that line. Yeah.
So if you wanted to call shoot on v, you'd have to cast v.
Correct. Exactly. If you wanted to send shoot to v, you'd have to probably ask v, is it a ship, and then cast it to ship, and then send the message. So good segue into this next thing, which is introspection, asking objects what they do. So So the question is, should we never use ID? It sounds bad. It causes all kinds of runtime crashes. And the answer is no, there's good reasons to use ID. One of the best reasons to use ID is when you're putting a whole bunch of different kinds of objects into an array. Okay, and you're going to be doing this in your assignment. You're going to be putting numbers into the array and strings into the array. And then when you pull them out, you're going to look and see what they are. And based on what they are, you're going to do different things. Okay, and that's a perfectly reasonable way to use a dynamically bound language. So how do we find out? And the answer is to use introspection. Okay? There's a lot of different introspection methods. I'm going to focus on these three. Is kind of class. You send it all, and these are methods in NSObject. So if you inherit from NSObject, which I told you all the objects we do in iOS, they all inherit from NSObject at their root. So you send this message to any NSObject, is kind of class, and it returns whether that object is that kind of class. Okay? Is member of class, same, except no inheritance. So that's asking you, are you specifically this class? Not, are you this class, or do you inherit from this class? And then responds to selector is, do you respond to this method? Okay, regardless of what class you are, do you respond to this method? Okay, so let's look at the syntax of these because it's a little funky syntax to understand. The arguments are a little weird. The class methods is kind of class and is member of class. The argument they take is what's called a class, a capital C class. It's a type def thing. It's not really an object. It's a special thing. It's a class. You get the class, capital C, from a class by sending it the class method class. Okay? Put a smiley face up there because I know it's a lot of the word class, but just look at how the code goes and you'll see. If obj is kind of class, square bracket, NSString class, close square bracket. That's how it works. So just substitute whatever class you're testing for NSString, and then you'll do it. So if that's true, then I can say NSString star equals open square bracket cast NSString star obj, which now I know is fine because I just checked to make sure that obj was a string first, and then I can send it string by appending string. Okay, which is a string method. Everyone got that? So that little square bracket NSString class, kind of goofy, but just do it. Then the selector one, response to selector, it takes a selector. Okay, selector is another special type def, SEL, capital S, capital E, capital L, and it takes the name of a method and it turns it into this magic thing that can be tested for. So here's how you would test to see if obj responds to shoot. You would say if square bracket obj responds to selector colon @ selector parentheses the name of the method. And if it had multiple arguments, this would just be, you know, foo colon bar colon whatever colon. Okay, the full name of the method including all the colons. This one has no colon, so it's just shoot. And if obj does respond to selector shoot, then I can just say obj shoot, because I've checked first to make sure that it responds to it. Does that make sense? You probably won't need this one for your assignment. You might be able to use it actually, but the is kind of class you'll definitely need. All right? So I know this @ selector thing is kind of goofy. You can actually store them in variables, local variables. It's of type SEL. Target action uses this. You know, button, target action stuff we do in Interface Builder. There's actually a method in button and all the target action things called add target action. So you add a target, who's going to be the target, and then action colon @ selector. Okay, that's basically how you specify a method name, if you want to think about that. But it's kind of some magic in the compiler, the preprocessor, to turn that into the right selector for the method. There's also kind of a cool feature in NSObject. If you have a selector, you can send a message to an object to tell it to perform that selector. Okay, there's two versions, one that takes one argument that's an object. It only works for limited kinds of methods, and one that takes no arguments. So just FYI, you won't need that for your assignment. So nil, I want to talk about nil briefly. I actually mentioned this last time, but I want to be clear about it. So nil is just the value an object pointer has when it's not pointing to an object. Okay? It's kind of like 0 for a primitive type, like int. In fact, it is 0. Okay? That pointer is 0. And that just means it's not pointing to anything right now. NSObject when the alloc in NSObject, it sets all instance variables to 0. Okay, so you can count on that when you're writing your code. You don't have to be setting your instance variables to 0. Some languages require that. Objective-C, as long as you're inheriting from NSObject, all your instance variables will be 0, including your object instance variables, so they'll be nil. They'll start out nil. So like in our calculator brain, we had that weighting operation. It starts out nil. You can implicitly test for nil by just saying if parentheses obj. And that will be true if obj is not nil, and it'll be false if obj is nil. Okay? So straightforward. Now the key about nil is to realize that sending messages to nil does not crash your program. It's not like dereferencing a null pointer. Okay? This is different from a lot of languages. Okay? If you send a message to an object that's nil, it basically does nothing. Actually does slightly better than nothing, which is if that method had a return type, it'll return 0. Okay? Which is kind of useful. Okay? It makes it easier to write your code. You know, if it's nil, it's perfectly, you basically, when you're writing your code, it's fine to design it such that having the object pointer being nil means something. And when you send that message and you get 0 back, that's fine. The only thing to watch out for here is structs. All right? If you return a C struct, like a CG point there, that will not have all its members zeroed out. It'll be undefined what that value is. Okay? So basically, don't use the fact that nil returns 0 if the return value is a struct. That's the only thing to watch out for there. But if it's an int or double or returns an object pointer, perfectly fine. It's not bad coding style to do that. You're rocking. Okay? It's very valuable. And you'll see how this works. This is really nice. This really makes for nice code over time. Bool, you know about bool. It can be implicitly tested if flag, if not flag. The two # defines we use are yes and no, not true and false, not lowercase yes and no, capital Y, capital E, capital S, and capital N, capital O. That's what we use. That's the convention. They're true and false are probably even # defined in there. The reality is 0 means no, and any non-zero means yes, but I would not use that. If you're having a bool variable, it should only have the value yes or no. Don't give it any other wacky values, like 0 or something like that. Okay? But it's okay to implicitly test it, if not flag. That's okay. Okay, so we do have time to go through some foundation, which is great. Gives us more time for our demo on Thursday, which I always have trouble having time to finish. So that was all I'm going to cover in Objective-C. We still haven't covered the big thing in Objective-C, which is memory management. I need to kind of show you some of these foundation things first before I can really have that make sense to you. But that will be the big topic for Thursday is memory management. Okay? If we're passing these objects around, returning them as properties, setting them, passing them as arguments to functions, who owns that memory? There's no garbage collection, so someone has to clean up all that mess. And so we're going to talk about that next time. But so for the rest of this time, I'm going to talk about as many of the objects in the foundation framework as I can. Okay? So the biggest object, most important object in foundation is NSObject. Okay? Like I said, it's the ultimate superclass. Pretty much everything we're going to do, every class. I don't think there's a single class you're going to create or use that is not eventually inherit from NSObject. The main things that NSObject does, memory management, okay, which we're going to talk about next time. That's probably its main thing. It also does the introspection. It has those methods like isKindOfClass and things like that, which really cover some C functions in the Objective-C runtime, but nice object-oriented methods. It has a great method description. Okay? That's the whole method, no arguments, just description, returns an NS string star. This is the method that gets sent when you put an object in an NS log or any printf-like thing with %@. Remember we did in the walkthrough, actually I don't think we did this in the actual demo for time reasons, but if you look in the walkthrough, middle of it somewhere, I do NS log and I put a %@ in there. And the argument I put, it happens to be a string object, but actually you can put any object there and just make sure that object implements description. And that'll be the string that gets printed out to your console. Okay? So that's a good one. You know, most objects like arrays and strings, they implement description for you, all the objects in the SDK. But if you have your own object like the calculator brain, you might want to implement description to print out the operand and the weighting operation or something like that so you can see what's going on in the log. NS string, probably the next most important object in foundation. just because there's a lot of strings going on in applications in the user interface and as IDs and other things inside of your application. They're international strings based on Unicode, okay, so they can represent any string in any language in the world, basically. They're used throughout iOS instead of CareStar. There's no iOS API that uses CareStar. They all use NS strings. All right? There's a lot of pre-compiler support for them, including the constant that you're already familiar with, this @ notation. One thing to notice about a string, it is immutable. It cannot be modified. Okay? NS string objects cannot be modified. Once you create them, they stay that way forever. Whether they're created with the @ thing, or you create them by doing string by appending string, or string with format. Any way you create them, doesn't matter. Strings cannot be modified. It's very important to understand that. Okay? So the usual pattern for using them then is you have an NS string that you want to modify, you send it a message to modify, and it sends you a new one. It returns a new string, okay, that is modified. You still have the old string, and it returns a new string that is modified in the way you're asking for. All right? So, for example, in our code from last week, we have display text string by appending string digit that actually returns, that takes the display text, which was a string, appends that digit to it, and returns a new string, which we then set as the text in the display. To use dot notation, it looks like this. Okay? So we see how we're taking the existing string that displays text, sending it a message to modify it, but we're not really modifying it. We're creating a new string. Okay? So everyone got that? So same thing here when we did the operand, we're updating the display, right? Now this is different. This is a class method. Do you recognize the difference here? We're sending this to NS string. So this is actually creating a new string out of the ether, all right? The NS string, the class, is creating a new instance for us using the string with format method. Okay? There are tons of utility functions available for NS string. I encourage you to go look it up in the documentation. Everything from case conversion, you can get substrings and append strings together, converting types, like we use strings double value method to turn it into a double, remember, in our calculator controller. So there's just tons and tons of functions in string. Very versatile class, very highly optimized as well. Now, for those of you who are worried because you can't modify NS string, there's a different class, NS mutable string, that you can modify. Okay? And it works as you might think. Like here I have a mutable string that I created by allocating and initting, and then I sent it the message append string, and it appended that digit onto the string. Right? So you see how that's a little different than returning a new string that had the thing appended on it. Notice the method name is a little bit different. Instead of string by appending string, it's called append string. All right? Mutable strings, you might ask, when do I use a mutable string versus an NS string? Well, if I'm doing some modification to a string in a tight loop, or I'm changing it, modifying it all the time, I'm probably going to want a mutable string that I'm modifying. But if I'm just returning a string, or like the case of our calculator, where I'm getting a string, modifying it, setting a new thing, generally you're going to use NS string, not NS mutable string. Okay? We wouldn't want to get the display's text. That's immutable anyway. We'd have to convert it to a mutable string, modify it, then set it back on the display, which would ignore the fact it's mutable anyway. It would just be using the immutable value of it. So it's pretty obvious when you want to use NS string. You use NS string almost all the time. NS mutable string, pretty rare to use. Okay? A few miscellaneous objects in Foundation. Yeah, question?
So with NS mutable string, can you access the indices of the characters?
Yeah, you can. The question is, in NS mutable string, can I grab a character out there, replace one, put a little, yeah, you can substrings, you can muck around with that string, you know, all you want. But, so yeah, it's not usual, as I say, but you can do it. So here's some miscellaneous objects in Foundation. I'm going to leave the other big class of them, which is arrays and dictionaries and sets. We're going to talk about that next time. But here I wanted to go over just four really kind of somewhat common objects that you need to write most general applications. One is NS number. You know, you've got these ints and doubles and floats running around like we have in our application. You can't put them in an object-oriented array. Okay? because they're not objects. They're primitive types. They're C types. So NSNumber is a class that allows you to wrap these primitive types in an object so you can put them in an array, right? So like here I'm creating a number by using the NSNumber class method number with float, and it's returning me a float object. And then I can, for example, get the primitive back by sending it float value, or I could put it in an array or a dictionary or something like that. NSValue is an even more general wrapper. You can actually wrap C structs and things like that. You know, the iOS provides NSValue wrappers for the common structs that it uses. If you wanted to wrap your own structs, you'd have to write your own wrapping code, which it's rare to do that. But if you want to put a point into an array, you use NSValue, okay, or a rectangle, those kind of structs. NSData, super important class. Anytime you have a bag of bits, unstructured data, maybe it's the data of an image or an HTML page that comes back or something like that, just generic untyped data, big bag of it, you use NSData. Okay? So there's a lot of API in iOS for passing this pieces of data around, getting them over the network, writing them out to files, converting them to different file formats, etc. Very common to use NSData. And its API is very straightforward. Init with, you know, char star usually, or byte star, and get byte star back, convert to Unicode, convert to NS strings, that kind of API. And then the last one I'm going to talk about today is NSDate. You can ask NSDate, what is the date and time right now? And it will tell you with some pretty high accuracy. You can also store dates. Okay, so this is a good way if you have your program is running and it wants to remember when the user did something and then report it to the user later. Like, you know, the last time you opened your favorites was Thursday at 5 p.m. Well, when they open the favorites, you create an NSDate object. You can store it out to various places, file system, or there's a way to store defaults, and then you can restore it. And there's some other ancillary classes that go along with NSDate, NSCalendar, date formatter, date components. These are what you would think they would be, getting things like the month and the day out of there. So that's how you deal with time, basically, in Foundation. Okay? So next time we'll talk about arrays and dictionaries and sets, enumeration, things like that, and then we'll talk about memory management. And then the end of it will be a demo that I'm going to do that's going to use introspection, and it's going to create some arrays and dictionaries, some NSNumbers, all that stuff, kind of put it all together in some code so you can see how this all really works. And that's it. So we'll see you next time.
For more, please visit us at stanford.edu.